Welcome back to Mr. Yasuda's math videos, and this one's going to be on the law of cosines and using the law of cosines to solve for a triangle when it's not a right triangle. So hopefully you've learned about the law of sines if you're watching this video. If you haven't learned about the law of sines, here you go, but you can go check out one of my two videos on that. Probably just the basics is good. And this video is going to be on the law of cosines, which you can see right here. So I would add them to my notes. That is the law of cosines. Pretty straightforward, though. You can kind of see if I give you a triangle here. Okay, so this is A, B, C, right? So you have side A, side B, side C. So if you take a look at the law of cosines, just some interesting patterns that you can see of it. If you have the opposite side will be alone, and then the cosine of the opposite angle will be over there, and then the other two sides will fill in the rest. And that's kind of how it goes. That's how I memorize it. So if I'm using b squared, then I know I have to use angle b, and then I have to use a and c in that part of the equation. And so you can kind of see how that would go. So opposite side with the opposite angle, and then using the other sides within that equation. Alright, so like the first question I want to ask is, when would you use the law of cosines? Right, so law of sines, hopefully you know how to do that, but law of cosines is going to come into play when you are given three pieces of information, and those three pieces of information, the first one could be side, angle, side. So you'll be given a side and another side, and you won't be given the angle that follows, you'll be given the angle that those two sides create. So that would be side, angle, side, and that would be a scenario where we want to use the law of cosines. The third one, or the second one, is side, side, side. So you may be given you will be given three pieces of information, but those three pieces of information will only be the sides, and you won't know the angle. So if you don't know the angle, and they only tell you three sides, then you know you got to use the law of cosines. So once again, when would you use it? Side, angle, side, and side, side, side. Okay, how to use it or why to use it, maybe. We can use it to find a missing side. Whoa, look at that, that was crazy. We can use it to find a missing side, or you want to use it to find a missing angle. Now the reason you see both law of sines and law of cosines up here is because I'm going to actually use the law of cosines, but then after that I'm going to use the law of sines when I can, because I just think the law of sines is a lot easier to use than the law of cosines. And so once I'm done using the law of cosines, I usually finish out the problem with the law of sines, but I kind of am strategic about how I do that. So here we go. Let's do the first one. Alright, so solve for the triangle. Side, angle, side is going to be the scenario that we start with. That'll be our first one, and then we'll do side, side, side. But here we go. First thing I have people do is I say draw a picture, right? And really the big deal is when you're getting ready for like a test or a quiz or anything like that, you're going to want to make sure that you draw a picture potentially if you can't visualize it, because you're going to want to see what information am I given. Because if you go back to law of sines, if you're given two sides and an angle, right, that create a side-side angle, then that's a whole different conversation. So you really want to make sure that you can see that it's side, angle, side. Alright, so there it is. There's our picture. Let's just real briefly talk about why we're going to choose the law of cosines over the law of sines. So we're going to use the law of cosines. And the reason being is, if you take a look at it, you realize, lost my train of thought there because my grandma called me, so you're welcome. I'm going to start over. Nonetheless, I think I was saying that you got to realize that you can't use the law of sines, because if you take a look at the stuff you don't have, right, if you take a look at the stuff you don't have, you've got angle B, angle C that you don't know, and you don't know side A. You can't use the law of sines because there's no complete proportion or complete fraction that you would be able to use to set up a good proportion. If you set up the proportion now, you'd have two variables and you wouldn't be able to solve. So we're going to use the law of cosines, and we're going to find the missing side with the law of cosines. So notice I could pick any of the ones that I want to use, but you want to make sure that you pick the one that uses angle A and obviously side A, and that's what we're trying to find. So if you go and pick A squared equals B squared plus C squared minus 2BC cosine of A, that's going to be the law of cosines that we use, and we can fill in something for all the different spots, right? So we can fill in something for B, since we know B, we know C, right? We know those, and we know angle A. And then we're going to be able to solve for side A using the law of cosine. So A squared equals 3 squared plus 10 squared minus 2 times 3 times 10 cosine of 55 degrees. Okay? And then we'll do the square root of both sides. So A equals the square root of, that would be 9 plus 100, which would be 109, minus, let's see, 2 times 3 times 10, what's that, 60? Cosine of 55. Please do not try to subtract 109 and 60. That is out of order, right? So from there, I just plug the rest into my calculator, and I'm going to round to the nearest hundredth. Make sure your calculator's in degrees. And I got 8.64. Alright. Now that we know that side A is 8.64, take a look. Now you have a complete proportion, or a complete fraction. And so you have thinking law of sines. Okay. And so I'm going to switch up and go and use the law of sines. But I'm going to be strategic about this. I'm going to use the law of sines to find the smaller angle of the two that are remaining. So between B and C, the smaller of the two would be angle B. So I'm going to use that, and I'm going to go sine of B over 3 equals the sine of 55 degrees over 8.64. So sine of B would equal 3 times the sine of 55 over 8.64, and B would equal the inverse sine of all that stuff, 3 sine of 55 over 8.64. So you might be asking yourself, why are you choosing the smaller angle? So that's going to require a quick discussion on the inverse sine. So inverse sine works this way. You plug in ratios, right? It's the opposite of sine, or inverse of sine. So we're going to plug in a ratio, and out would come the angle. And if you remember in our discussion about the inverse, right, the angles, right, the range that inverse sine uses goes from negative 90, which is unhelpful when dealing with triangles, to 90 degrees. And so when you think about it, why did I ask for the smaller angle? Well, inverse sine could, at maximum, tell you 90 degrees is the angle measure. And so my question to you is if you had tried to find a bigger angle than the smaller angle, what if it was obtuse? Well, if it's obtuse, inverse sine is not going to go over, right? It's not going to go over 90 degrees. And so you'd have to use something like the law of cosines to find the bigger angle, and law of cosines can be a little bit more tedious when you're looking for an angle. So I just use the inverse sine to find the smaller angle, and in this scenario, then after I have two angles, I can then subtract from 180. So the inverse sine is more helpful when you're dealing with angles that are less than 90. So B would equal approximately about 16.52 degrees. And then we can find, right, so that's angle B. So then we can find angle C by doing 180 minus 55 minus 16.52, which will most definitely be obtuse, and that's going to be 108.48 degrees. And we wouldn't have been able to get that from the inverse sine. So if you want to be able to use law of sines and go a little bit quicker, you're going to want to find the smaller angle. And there's our three missing pieces that we weren't given. And that's how you use the law of cosines. The law of cosines really just gets the ball rolling, and then we can let law of sines take over. Let's take a look at side, 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 and see what we would have to do here. So here's my picture. I'll call this C, call this B, call this A, 6, 8, 12. Alright, so notice we're given no angles, so since we don't have an angle at all, we can't use law of sines because you don't have a complete fraction there. And we're going to use the law of cosines to find the missing angle, or to find a missing angle. But I'm going to be real strategic again here, and I'm going to use the law of cosines. Right, can be used to find, and I'm going to go with the largest angle, right? And that's for the exact reason of we're going to be using the inverse cosine, and the inverse cosine, right, you plug in a ratio of some kind, some x value, and then out will come an angle. Well, based off our discussion of those angles that come out, right, of the range of the inverse cosine, it's from 0 degrees to 180 degrees. So if I find the largest angle, which in this case would be angle C, right, then if angle C is obtuse, the inverse cosine would let me know that. And so that's why I'm going to go with the largest angle first. So that means if I'm going to find angle C, I want to use C squared equals A squared plus B squared minus 2AB cosine of C. We're going to plug in what we know. So we know 12 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 cosine of C. So notice the angle is what I am trying to find. And so I am going to get everything away from the cosine of C. So I'm first going to do some algebra to get everything away from that, and then I'll use the inverse cosine. But we shouldn't be doing that until we've first gotten everything away. So let's do some math. 144 equals 36 plus 64 minus 12 times 8. Is that 96? Gotta know my times tables. Cosine of C, that's going to be 100, so 144, right, equals 100 minus 96 cosine of C. And then I'm going to subtract 100. I can't combine the 100 and the 96. That'd be bad math. So that's 44 equals negative 96 cosine of C. Divide by negative 96. And if you can think about this to yourself, right, I'm not even going to reduce this, unnecessary. Cosine of C equals negative, right, 44 over 96. And if you think about it, if the inverse cosine, right, is going to have a negative ratio plugged in, then the angle that's going to get plugged in is going to be in the second quadrant. And so I'm guessing that C is probably going to be obtuse, which is good because I could have never gotten that from the law of sines. So that's why you want to pick the largest angle first. So here we go. C is going to be the inverse cosine of negative 44 over 96. Just make sure your calculator is in degrees and it will tell you the angle that you need. Alright, and after plugging it in my calculator, I got 117.28 degrees. So since we know this is 117.28 degrees, hopefully you can see that now we can use the law of sines And once again, I'm going to use the law of sines to find the smaller angle. So in this case, I'm going to find angle A. So sine of A over 6 equals sine of 117.28 over 12. Now we'll get sine of A equals 6 sine of 117.28 over 12, and then A would be inverse sine of 6 . Okay, so using your calculator, you should be able to find angle A. Alright, so I found angle A to be 26.38 degrees, and then we can find our final angle, right? We can find angle, so that's angle A, that's angle C, and we can do angle B by subtracting from 180. Minus 117.28 minus 26.38. Plug that into my calculator, and angle B will come out to be 36.34 degrees. Okay, and so we were given 3 sides and we found 3 missing sides. In conclusion, law of cosines does not have to have that discussion about 0 or 2 triangles or anything like that. So when you're given side, 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 you know there's just one triangle, and when you're given side, angle, side, you know there's just one triangle. And if you're strategic about solving the way that I did, you should be just fine in finding the right answer every time. Just make sure your calculator's in degrees. Alright? If you enjoyed the video, like and subscribe. If you have questions, leave them in the comments. Or I don't know if you can email me, but if you're one of my students, you can. So anyway, cool. Peace out.